Good evening. My name is Dr. Sanjay Suresh, and I am a student in University of New England taking genetics course 1040. So today in this video, I'll be talking about gene mapping and how do we map the genes and how do we calculate certain values. So the first thing we do is I have set up a table, and in this table, the first thing that we need to see is we need to find out the parental genes. And how do we find out this parental genes? Well, it's really obvious. We just see the values that are occurring most frequently. We see the ones that frequently occur, and that is obviously our parental gene. So in this example, in the slide that I have provided along with my presentation, the frequently observed genotypes is + and ABC. So this is our frequently appearing parental genes. And next, what are some other values that we could find out? Well, we have some other values along other than this parental. These are called as a double crossovers and the single crossovers. So what are these double? How do we find out these double crossovers? Well, all we do is we see the lowest values in the given data set. So the lowest values in our example is 100 and 140. So this is our double crossovers. So using these values, we can find the other information. Now let's talk about how to see a gene map, how to use how to see the gene map. So we have points A and we have points B, and we have a recessive allele C in the middle. So what do we do is if we have the recessive allele C between points A and B, and then if we also have a dominant allele C between little a, little b, we know that they are all in the same map. So we can use this set of values to determine the linkage distances between these genes. So this is the basic method. Now I will talk about some calculations. So the first calculation is we see the observed DCO. The DCO basically stands for double crossover. So how do we find out this observed DCO? It's simple. All we do is we see all the values of double crossover. So we see all the double crossover values and we just add them all up, and that gives us our observed DCO. The second thing is we want to find out the coefficient of coincidence. So for this, we use the formula observed DCO over the expected DCO. Now we can find out the expected, once we find out the expected DCO, all we have to do is we just divide the observed DCO or the expected DCO, and this gives us our coefficient of coincidence, which is given in the slide, and I have prepared some calculations in the slide. So this is how we get our observed or expected. And the last thing is we also have something called the interference. So what is this interference? It's a simple calculation. All we do is we take 1 minus the coefficient of coincidence. So in this case, in my example, we just subtracted 1 minus the coefficient of the COC value, and we got a value of 0.39. So this gives us an interference of a value 0.39. So these are some basic calculations, and by using this, we can identify what genes are present where, and it can also help us in mapping of the genes and finding out the locations, and all the other calculations are given in the table as described. Thank you.